Hey, welcome back, everyone. Well, slightly less people returned after the beer break, but that probably has nothing to do with the upcoming content.
Let's hope.
We work together with Levy9 a lot. Nowadays, some of the development capacity and the testing capacity is provided by you guys from either Ukraine or Serbia. Yeah, you're based out of the Netherlands, actually.
Yep.
With a story about automated testing
And feedback.
getting the
mostly
feedback
yeah.
into the process as soon as possible.
Mhm.
So give a round of applause for Pavel.
Okay, so my name is Pavel Chunyayev, and I'm continuous delivery architect at Levy9 IT Services. With my daily work, I help companies to assess, improve, and optimize the way they deliver applications to production. And then I'm going to talk about feedback, and well, general continuous delivery and how feedback is created there. And I'm not asking you to believe me or just trust me or think that everything I'm saying true. I'm just asking you the opposite. Be skeptical about everything I'm saying and find the flaws in everything and provide me feedback either via Twitter or just personally after the talk, okay? Good. So quickly about Levy9, we're a company of 700 people with head office in Amsterdam and working from 3 countries, Ukraine, Romania, and Serbia. A lot of companies, but mostly from Dutch market, and we also work for Sanoma. Last year, we reached 100% customer recommendation score. About me quickly, I come from Ukraine. I used also to live in Estonia. 2 years ago, I moved here. I love cycling, and I found out this when I moved here, obviously. And now I also have a race fits, road bike. I'm learning the Dutch language. It's been 2 years. I'm still not at the level where I'm feeling comfortable speaking, but I'm trying my best, just believe me. I love software development processes, and this is where I believe feedback and ideas of feedback will kick in. And I love working with people. Yeah, this is what I'm doing. So to start with feedback, to start with definition, feedback is the information about actions returned to the source of those actions. And feedback has applications in different fields of science, like engineering, biology, economics, acoustics, but also it has a good place in software development. This is how it looks like. Generally, feedbacks, is that taking the output and feeding it back to the input of the system to change the behavior. This is how we create adaptive systems that react on external factors. And there are 2 main types of feedback loops that you can create. The positive feedback loop, a feedback loop that increases behavior, that reinforces this growth, or facilitates the behavior that you want to facilitate. Or negative feedback loop, the feedback loop that wants to degrade or stop the behavior that you don't want to happen. And again, in the processes, it's all over there. To move to the process, I would like first to share about what I think continuous delivery is, being continuous delivery architect, right? Because, well, different people think differently about what it is and which part does it play. So I think that this is continuous delivery. It's the idea how we move from the idea for business towards the production. And this is full end-to-end process. This is what continuous delivery. And how we optimize this process end-to-end. Because this is what actually we need. Not every feature is needed by users. So we come up with feature, go through this whole process, and validate it at the end. And we need to go quicker and quicker and quicker, as quick as possible from one end to another to be able to go there. So we need to release more features in less amount of time. But it's not only about speed. And I would like to, well, to say this loudly, quality is more important than speed. You can only gain speed if you put all your attention into quality. This is also the first feedback that you can provide to this. If you can, through going through quality, through constantly checking the quality, you can see that we can move faster and faster and faster and facilitate the speed that you want. And you can do it by 2 main things: keeping the product releasable. With every change you make, with every tiny change you made, still keep it releasable. And build the quality into the software development process. Move test to the left, this is also called. How it looks like for most people, continuous delivery happens here on the build, test, and release phase. Because on one part of it, we throw in the source code. On the other end of it, we just have a working piece of software. On the build stage, we do everything we need to do with the source code. Just linting, static code analysis, some dynamic code analysis, security, static code analysis, whatever. And then we create an artifact, create a binary, we version it, and we put it somewhere, well, where we store the artifacts. And then we only work to artifacts. Then we run the testing, all the testing that is needed. And then we move to releasing, deployment, downstream integration, whatever is happening there. But the testing is the interesting part, because here I believe we can run all the testing that is needed to check if the application is the one, and if the application, to challenge it against the criteria that we set. And for that, we always need to create infrastructure and then dispose infrastructure afterwards. This is the great idea that I want to share it with you, because only like this you can run a lot of tests in parallel, and you can create a short feedback loop without hours and hours of running the test, by parallelizing it and by creating infrastructure and then destroying infrastructure, but not having the DTAP street. And this happens on every level, regardless if we're creating libraries or building blocks and then delivering application. On every level, this must happen. Even if we're creating package application, we need to reassemble it and then retest it again. But the idea of moving tests to the left is that you need to start them as early as possible. And if we're having a component that is then integrated into bigger application, we need to test it fully on its own pipeline, not on the integrated application, because we need to provide quick feedback to the developers. Okay, feedback. Feedback, I believe, is one of the important parts of any agile or lean processes of Scrum that we're doing, because we always need to see, are we on track? Is the team happy? How are we doing? When the feature probably will be delivered, in 1 month, in 3 sprints, when it will be delivered, and how do we need to do? And it comes in various forms, but the most important form of the feedback is measurements. If we want to measure something, we want to measure it to provide feedback for developers. If we're measuring it for any other purposes, why are we doing this? Who will read this information? Who will change their behavior based on it? So metric is the form of feedback. What kind of feedback exists in a continuous delivery here? Let's start with developers. All these stages provide feedback to developers. On the build stage, actually, it is super simple. We can run some unit tests, integration tests. I will talk about them shortly. But then, most important part is my application still built-in or not? And this is something that you can easily and quickly check itself. The test, something that not in every company I see developers receive feedback from here. But this is the important part. Is the application working correctly? Are we building the right thing? Are we building the thing right? This is the feedback that tests might provide. Release. Either it is a deployment to production, how did it go? Correctly or not? Or downstream integrations, how did it integrate with the other application? This is the type of feedback we're looking. And finally, operation. Here also, in a lot of companies, this just doesn't exist. How application is performing on production? How should we change it so it's performing better? If testing is done by somebody else but by the team, this feedback just doesn't exist, and the team has no clue. If operations team is running by somebody else, operations is running or releasing, this just feedback doesn't exist, and this is what creates silos. If there is no feedback, you have no information, the silo is immediately created. For the business wants feedback from every stage, obviously. From the planning first, okay, how do we refine the feature? When probably it will be delivered? How they're coding it? Is it fine? How the sprint is going? What's the burn down chart? Is everything okay or not? Same with the builds. Well, green build probably is the feedback management wants to receive, a red build not. But this is the feedback that they're looking. How many builds a day do we do? How often do we do this continuous integration? Same with the testing. But here they're looking already on a different type of testing. Again, I will shortly talk about this quickly afterwards. But then they're checking, is the software that is built providing the functions that we need, the functionality that we requested. Same release. How did it go? Is it okay or not? And operations. Are we making money? Are we losing money? Is the feature used by users? Is anyone is it needed even or not? But also, what I believe is needed and what is missing in a lot of places is the feedback from this envision step and planning to the developers. With the planning step is more of a roadmap. When are we going to work on some of the features? In many companies, I see developers have no idea. For them, there is a sprint, and then some more work will come, or the Kanban, and then some more work will come. Or they envision, what are those ideas that come from management? This is like a question, why are we doing this? Who are we doing this for? I believe that this is the important part that developers team needs in everyday work, because you can have a lot of everyday decisions and you need some framework to judge those decisions. If you don't have opportunity to judge them against this bigger why are we doing this, it's just harder to do. In the same way, you can show the same picture like this. This is the idea of the lean startup or lean enterprise, the build, measure, learn cycle. But the idea is still the same. We need to come up with the idea, and then it's probably needed by users. But then go through the loop of creating this idea, see how it's used by users, and based on this data, make a decision to invest further on it or not, or maybe to stop doing this correctly, or pivot if you're a startup. Okay. Quickly about pyramid, everyone knows the testing pyramid, but still, execution time, well, testing pyramid shows the amount of tests that should be ideally present. Execution time increases, business feedback increases when we go to the top, developer feedback increases when we go to the bottom. Right, but I would like to talk about the type of testing and the feedback. Unit testing, very important type of testing that provides most feedback to developers. It never provides feedback to business because, well, the unit test has failed, so what? But for developers, this is, if the tests are created correctly, this is the feedback that you're looking for, because then you know what should be fixed. And this is, of course, we're talking about testing methods or objects, but it's important to have most unit tests, and not only the happy part, but also something that lies outside of the boundaries. Then we go to integration testing, how different units communicate with each other, because it's all about communication. And here we're looking how the whole application component or microservice is working internally as a whole. But this also provides feedback to development. How your application is working. Are we still on the right track creating the application in correct way? Then we move to contract testing, something where we're taking the boundary of the whole component or the whole microservice, and we abstract from what's happening inside, but we're looking at it from outside. This is why it's called a contract. If we're exposing this contract as a REST API, people call it API test. But this is important part of testing that provides feedback to development, but also provides feedback to business already, because here we're talking about, we're exposing API, we're exposing contract, it's business functions that your component or your microservice provides. And regardless how it's integrated through REST API, through the message bus or enterprise service bus, wherever, there is a contract and we must test it, and it provides feedback how our application is behaving. Then we move to end-to-end testing. This is how different microservices or different components work together. And this is already testing your application as a whole. This is where we're talking about customer journeys, about personas, or user flows, however you call it. But this should be not a lot of those tests. And these developers should not rely on these tests in their everyday work to make decisions. But these tests ideally should never fail. They should only provide feedback to business. Yeah, we're on the right track. The functionality that you requested is still there, or it's been implemented. We are good to go. Of course, it's not always like that. Then, yeah, what I want to say here is that to me it's an interesting, if we abstract, we go from internally from microservices, and these are called unit tests. We're testing different objects or their methods, and then we go into integration tests, how they communicate. But if we really abstract on it and move to the level of microservices, this is really the same. We can think that the contract tests are actually unit testing, if we just take it, the microservice as a unit. And how they communicate together is integration test. It's just depending on what you put as an abstraction layer, how do you look at this? Do you look inside the code, or do you look at the bigger picture? But to me, they look more or less the same. Of course, they implemented completely different way, but on idea level, they're similar. The contract testing, what do I want to say about contract testing? Because it's easy to arrange the contract testing. It's hard to change the contracts. Ideally, you have only one try to create a good contract, and then you should never change it. Because it's costly to change the contract. It's what your users started using, or the other applications or other services. You need to spend money and time on that. Of course, it's not always possible. You have to transition those, and by transitioning, you need to run several of them together. So if we got the contract version 1.0 and we want to change something, we call it 1.1. We run them simultaneously together. And then we beg people, please go towards our new version of contract. And they start transitioning after months, maybe weeks, years if you're not so lucky. And only after they all transition to a new version, only then you can stop using the older one. And this is a very costly process, and this is why we're talking about trying to create correct contract in the first place. But if you're looking on the feedback, yeah, we need to check that we don't break the stuff these guys are using. And this is what we're doing here. There is a big debate, should we do consumer-driven contract testing or producer-driven contract testing? I don't have time in this slot to talk about this, sorry. But anyway, don't break the contract. This is the most important part. Performance testing provides really important feedback to both development and to both business. For development is how the code is operating. And there was, of course, a joke that you need to put developers into the page duties so they can see how the application is performing. So only then they will start producing good code and the performance code. But it also for business, how application is performing, how many users I can serve, how does application scale. All of this feedback is important. Manual testing. Yeah, I'm not a fan of manual testing, and I prefer, well, exploratory testing here. And I believe exploratory testing is very important, not like manual testing, because it's not part of the real delivery process, but it helps people thinking and looking into application through the eyes of the user and find out new ways of testing applications, or for developers to think through, again, through the eyes of the user. And you can also do exploratory testing. You can test something that you just can't test automatically, or come up with a new test as well. Resilience testing, very important for something like microservice architecture, because you want to see what happens if this service dies, or this one, or those two, or just whole application completely dies. How will it perform? Because you want to serve users still, maybe in degraded mode, maybe not provide whole functionality. And this is also the feedback that these testing provide. How will it perform? Who creates tests? Ideally, I think the tests need to be created by developers. Unfortunately, this is hard to do. Developers are notoriously bad in creating good tests. There is even saying that there is one view how to build stuff and one view how to break stuff. But this is quickly changing. And I believe the role of QA is changing quickly as well. So QAs will have to become developers and create both code and test, and they will be good at test, maybe less good at code initially, but then they will pick up, or become facilitators to help developers learn how to test the applications. Because, well, who would better create tests but the guy or girl who creates the code? I don't think so. Yeah, some more things, instability and slowness of tests. So I see in some teams in stable tests, and the behavior is like, oh yeah, the test is red, the build is red, just try to run it again. And this is like bad feedback, because it facilitates absolutely wrong behavior to just try rerun the test. It's okay that the tests are red. Like, what kind of feedback is that? So it's better to disable those tests completely. They are providing wrong feedback to you, or just make them stable, that they always produce the same result. Easier said than done, I know, but then again, you need to disable those. Otherwise, you're just facilitating wrong behavior. Same with the slowness. If the result of the test, if the feedback loop, if those results come a lot later, like in hours or days, there is a context switch. You completely forgotten what you were doing. This is just too late. So you need to try to provide the feedback from the test as soon as possible. And we can parallelize those. Immutable infrastructure helps. Container help. All of those things help. Sorry, not enough time to talk about this. Release versus the deployment. Yeah. I want to separate those two because deployment is an act of putting code to the server. Release is an act of enabling those code for the users. A lot of things can happen here, but deployment provides feedback that we are still on track and we can produce more features and we can deliver them to production. Release shows that, okay, the feedback users have started using it or not. This is also something you want to find out. So yeah, feedback. Creating adaptive systems and adaptive processes. We want to, for development teams and members of the team to produce the behavior that we want. And for this, we need to create feedback loops that will facilitate this behavior. This is what I was talking about today, about keeping the product releasable, building the quality in. You need to iterate fast as well, and, well, shorten the feedback loops. This is it. Thank you.
Can you sit up? Any questions for Pavel? Hans? Nothing? What's this?
I'm not sure if it's good or bad. I will take it for good.
It's always a risk being after a break.
Yeah.
Usually the drink break is fine. Can you unplug so that
Yeah, absolutely.
Ari can start setting up? No questions. Anton, think of something. One sec, give you the mic.
It's mine. Yep.
Yeah, I have a question, which is, for example, when you're dealing with microservices or a simple service that has external dependencies, like, for example, an API, what's your suggestion on best practices for testing them? Like, should you mock the external API, or when you're running a test, should you have, a real instance of the API that you're testing, but then that creates a dependency in the test setup? Sometimes the infrastructure for testing is difficult to set up if there are lots of dependencies. Well, any thoughts on that?
So you're asking how to deal with third-party services
if you have, a service A that utilizes API B, should we mock the API B or have an instance of API B on that specific to the test build? And what if there are multiple versions of API B?
So to me, it should not matter in your process whether you're testing with the third-party integration or service or your internal service. They should be treated identically. So there can be different scenarios, but for one scenario, you can just mock those services if you don't want to rely on the problems that they can do. But in most cases, you want to run them in real life. But that depends really on the type of this service that provides. So there is no good answer here. For the service that provides you that you can easily run on some on the test environment, not only in production, it's easy to use them a real service, especially if you can have a lot of instances or a lot of accounts. But something like, for example, with the banking service, you probably don't want to do it, or you want to have a special test version of this third-party integration. But there is no good answer. It depends on what exact integration we're talking about. Generally, I would say in a lot of cases, if and a lot of those services have RAML or Swagger specification, you can easily plug it into your test and mock those. But it's not every time good result. Sorry, no good answer yet so far.
Cool. Final question for Pavel. Yeah.
No.
Hi. A question about basically what you said. Ideally, developers should test also, because I think most of the things they speak for themselves.
Mm-hmm.
But how would you go about having, putting this in process to motivate the developers more? Starting out with just saying they should do it, or how can you create an environment where this basically takes place and takes off? That's, I think.
Well, I saw one transition where QA engineers were really interested into testing and creating code, and eventually they started fixing the bugs that developers produce, and they started working together with developers, and they became developers, and they started creating code. And then this was an interesting behavior, because the rest of developers were just coding but not creating tests, and they were like, these guys can code, they can create tests, we need to learn from them. And they were pairing, and with this they started learning how to even look into this. So I believe the best way is to pair QA and developers, so both learn from each other. I'm not sure if this works in every team, because again, all of the situations differ, but I believe pair programming is one of the good ways, or teaching developers just how to test.
Basically, it also goes back indirectly to the front of the chain to ask basically the business to have more patience, because this will take some time.
What I see generally,
So I think it requires something, some slack from the business as well.
I see it actually in a bit of a different way. I see that it makes things faster actually. It's a bit counterintuitive, but if you don't test later in the process, you don't have rework. And this makes everyone work a lot faster. Again, it's a bit counterintuitive, because